We have the graph, we're told to graph the derivative of the function f, whose graph is, this is the graph of f prime. And we got to think about the terms of the behavior. So here's what's going on. This is a little bit challenging, but after a while you get used to it. If I were to ask you what type of function this is, what would you say it is? It's some variation of x raised to what power? Third power, right? So this is a cubic. This function is a cubic.
Yes, it is.
What is that?
Looks like
Yeah, it looks like a parabola, which is x squared. So that's no accident. Now, if you were to look back at all the derivatives that we have taken, for example, just before I started recording this video, I showed you guys a shortcut and I said I wouldn't explain it. And maybe I will a little bit. I said, hey, if I've got this really complicated function here, I've got f of x is 4x squared. This is a second degree polynomial, but notice that f prime is a first degree polynomial.
so it's one less.
Yeah, we lose a degree. And now when I show you the power rule, it'll make more sense. But basically, when you go through that formal thing, when you cancel the top and bottom, you're going to be 1 degree less. So this is a cubic, and f prime is a square. Now, in terms of the relationship between the two, and notice that the notation here we have y and y prime. And I said this before, so let's just review real quick the different notations. These are all the ways that we could take or write down derivatives. Y prime, it's pronounced y prime. Dy dx is another way to note it. Df of dx, that's the derivative of f with respect to x. This is the derivative of y with respect to x. And then we have d dx of f of x. All three of them mean derivative.
Ninth graders, M through Z, please go get your vision testing in room 109. Ninth grade, M through Z.
Why did they say two?
So y is this function, which is f of x, so y equals f of x, and y prime is just f prime. So now, f prime represents the slope. So at point A, our slope is positive, right? Now, as I get closer and closer to B, and just think of this paperclip as the tangent line. When I get to point B, my tangent line is more or less, is the slope more or less at B from A? Think of the numerical value. This is a steeper slope, which means it has a higher numerical value. At point B, it has a positive value, right? That's a positive slope, but it's less positive, correct? Now let's look at the derivative. The derivative here at point A, my slope is 4. I know that my slope's 4 because I went up 4 over 1. So my slope is 4 at A prime. But at point B, it's less positive. It's still positive, but less positive. Now let's look at C. At point C on my original function, what is the slope at point C? What is my slope at point C? 0. What is my value of f prime at point C? 0. Now, at point D, is my slope positive or negative?
Negative.
Negative. What is my y value at point D on f prime?
-1.
Negative, right? As I go to E, is it more or less negative?
More.
Well, it's actually probably close to the same, right? So here we have E, that's still negative. What is the slope at F? 0. What is my y value of f prime at f? 0. See the relationship? So now the x values are the same for everything, and so basically this is some variation of x cubed. When I take the derivative, I get some variation of x squared, and that's the relationship between the two. Does anybody have any questions on that?